Part 4 of the ECG review, we're going to talk about some aspects of MI, what to look for on the 12 lead. We're going to talk about the progression of the ST segment. We're also going to talk about some waveform changes, including the ST segment elevation or depression, T-wave inversion, Q waves, and changes, dynamic changes with the T-wave. So our objectives: number 1, identify the progression of the ST segment in relation to myocardial ischemia, injury, or infarction. Differentiate between subendocardial and transmural infarction. Describe reciprocal changes, and identify Q wave formation and T wave changes. So looking at the ST segment progression, so of course we always find our J point, and on top of that we also look at our T wave. Do we have a RT discordance, which means one is upright and one is flipped? But remember, with the changes, typically when you're normal, you're going to have a baseline ST segment and you're going to have an upright T wave. But as you become ischemic, and remember, ischemia can be reversed, you may have T wave inversion, and then you're going to start having ST depression. As the myocardial tissue becomes injured, you're going to start seeing ST elevation, and as it gets worse off, you're going to start seeing the formation of Q waves as the ST segment continues to elevate. So ischemia is the first on the continuum, and ischemia can be reversed if recognized early. The area of ischemia is more negative than the surrounding tissue, so that might be one of the reasons why you have a flipped T wave and ST depression. Repolarization occurs along an abnormal pathway, causing the T wave inversion. So again, with ischemia, you're going to see possible flip T wave, and you're going to start seeing ST depression. So it's going to start going below baseline. With injury may not always be able to be reversed. Injured area does not repolarize completely, and it thus remains more positive. The ST segment elevation and or T wave inversion, so the T wave stays flipped, but now at our J point we're going to see that it is elevated above baseline. Elevation usually occurs in 2 or more contiguous leads, and so this is going to be important for us to identify. STEMI, especially when we get to MI, is the concept of contiguous leads, which we spoke about in one of the previous reviews. So, with acute myocardial infarction, this is cell death. Part of the cardiac muscle is deprived of blood flow long enough to become infarcted and to undergo necrosis. Now, you've got a couple of different types that you may have, and the location and the size of the MI depends on which artery is blocked and where. You've got a subendocardial myocardial infarction where only the inner layer of the muscle is affected. And then you've got a transmural myocardial infarction, and in this case, the infarct extends to the entire wall. So in this case here, you see that you've got 3 zones of infarction. You've got your zone of infarction, you've got your zone of injury, and you've got your zone of ischemia. So if you notice in the zone of ischemia, it gives you an example here of a flipped T wave. In the zone of injury, you're starting to have a little bit of a Q wave, but you're having ST elevation. And in the zone of infarction, now you've got a Q wave and you've got substantial ST elevation. Reciprocal changes. So just as contiguous leads all look at the exact same or the same general location, reciprocal changes look at the same location but on the other side. So it's almost like a mirror image. So reciprocal changes oppose primary JST and T wave changes in the ECG. So if leads 2, 3, and AVF are reciprocal with leads 1 and AVL, if I have ST elevation in 2, 3 AVF, I should expect to see ST depression in leads 1 and AVL. This is one of the ways that we could tell a posterior MI, even though we don't have a V7, 8, and 9, because we may see ST depression or a even a very tall R wave in V1 or V2, which could indicate ST elevation or a Q wave in your posterior leads. So an example here would be leads 1 in AVL here, so you see ST elevation in 1 in AVL. On the flip side, you see ST depression in 2, 3 in AVF. So those are your reciprocal changes. So Q waves, physiological Q waves should measure less than 1 millimeter. Pathological Q waves, or Q waves that are involved in MI, are going to be deeper. And typically the general rule is 1 small square equals 1 millimeter. And so if you have several millimeters, it's going to be deeper. And the rule is deeper than 1/3 the height of the QRS complex. So in this case, we see that we've got a real deep Q wave, and it is much bigger than the R wave here. So here's an example of a physiological Q wave where that's what you would see on a normal ECG. And a pathological, obviously you see some ST elevation here and development of Q wave here. Here's another example where we've got a normal situation here, but if you look in leads 2 and then especially lead 3 in AVF, you see Q wave development. So general rule in your limb leads, 1 millimeter above baseline for your ST elevation, then we start to look, and 2 millimeters above baseline in your chest leads or your precordial leads. Your T wave is your most dynamic wave. It can be affected by hyperkalemia, hypokalemia. It can be affected by a lot of different things, ischemia, hypoxia. The TP segment is a period of electrical silence, which is this right here, which would be during phase 4. T-wave inversion usually is because of acute ischemia. And peak T waves are going to be because of hyperkalemia. And this ends part 4.